We are live.
Wow, oh my God.
Well, what happened? So welcome to another virtual jug session. We must be in the 60s now. I was just about to say, if you don't see the video, please refresh, which would have been the most defunct comment in the world, because obviously people wouldn't be able to see the video and therefore see me saying that. But anyway, joining us today, we have a Google Hangout support engineer, just in case our Hangout goes down, right? Welcome, Ray, to the VJug session. How are you doing, Ray?
Hello, doing pretty well. Thank you for having me here.
Oh, it's our pleasure, Ray. Now, Ray Sang, you're a Google employee for about the last couple of years, 2.5 years?
Yeah, that's right. Yeah.
And you work on the Google Platform developer advocacy team, correct?
That's right, yeah.
What does that mean? What do you do on a day-to-day basis?
So there are really two things I do primarily. One is to bring some of the latest and greatest technology that Google has to offer to developers. And the other side of it is to actually get all the developers' feedback and your experiences using our technology or actually other people's technology as well, so that we can actually make our products better. So that's really the core of my job.
Awesome, that's super important as well. From anything developer-oriented, it's super important to get that feedback so that people don't just develop what they think people need, but you're getting the end usage and you can feed that back.
Right. Yeah. Yeah.
Excellent.
Yeah. Absolutely.
And so you do a lot of Kubernetes work as well.
Yeah. Yeah. So I've been looking into Kubernetes for the past year or so. Yeah. So actually, prior to joining Google, I was at Red Hat, and I was working with OpenShift at that time. And then I joined Google for like a year. I was working in advertisement, which I knew nothing about. And then I came out, I'm like, what is this new Kubernetes thing? Yeah.
So Red Hat to Google, would you consider that a promotion or a demotion? You don't have to answer that. I was joking.
That was good. Yeah, they're both great companies.
They are indeed. And so joining us today on the call as well, our local resident Oleg to the VJug. Welcome, Oleg. How are you doing?
Hey people, I'm doing great. The first day at work after the vacation, so I'm full of energy. Happy to be here at the session. Glad I'm not missing it.
I was going to say, you look very relaxed right now. It looks like you've had a break.
Yeah. Can you see some tan? No, you cannot, but allegedly there is some.
It's all right. I'm going to share my screen quickly. So hopefully, look at that. Quick lesson in recursion for everyone there. Right. How can you see my screen?
We can.
You can, perfect. Okay, so this is just to let everyone know the session we're going to be talking about is developing Java-based microservices with Kubernetes with Ray Sang. And actually, I didn't mention Ray's Twitter ID, which is @Saturnism. Oleg, maybe perhaps you could paste that URL for Ray's Twitter handle into IRC. The VJug is sponsored by Zero Turnaround. Rebel Labs is the media partner as well. If you're interested in some of the revolutionary developer tools which Zero Turnaround provides, such as JRebel or XRebel, which allows you to reload your Java changes instantly, or check out your profiling and your performance testing during development, you're welcome to go to zeroturnaround.com and grab some free trials for that. One other thing about today's session, if you would like to participate, you can go to virtualjug.com. And you can enable the IRC widget. You can ask loads of questions there, and you can add as much discussion as you want, and I'll pose the questions that you ask directly to Ray. If you are just using an IRC client by itself, you can go to #virtualjug on the Freenode servers, and you can find our channel from there. Please do share the group and session. We're almost up to 6,000 members now, so while you're sitting there, please grab Twitter or whatever you use and say I'm watching the awesome Ray Sang or awesome @Saturnism on the Virtual Jug, and do link back to the site. Any feedback about the jug or about the session, please do tweet me @virtualjug or @sjmaple, and I'll get that information. Now, this is a very big day today because we are going to be announcing something. Actually, no, so it's going to be a very big day tomorrow, but I'm going to give you a pre-announce. I'm going to announce something called VJug 24. And VJug 24, which we're going to be launching tomorrow, is a 24-hour virtual conference, which is happening on September the 27th this year, the week after Java 1 this year. And this is going to be 24 sessions, contiguous sessions, lasting an entire day, 24 hours. And we're going to invite speakers to submit for a call for paper. We're going to invite Java user groups to join the sessions with us as we go around the planet. And we're also going to invite companies to sponsor us, sponsor every single session, so that we can provide the Java user group, which are going to be joining us, with refreshments as well as a bunch of swag. So do check out that announcement, which is going to be coming out tomorrow. I'll also be adding a VJUG 24 event to the meetup page, and my good friend Oleg and I are going to be awake for 24 fine hours listening to some amazing tech, hoping that we're going to get Red Bull to sponsor us, because I think we're going to need it. So that's everything I have at the moment. So let me stop screen sharing. I hope that's really, really exciting. So I hope you guys are all going to be really excited and joining us on that. And wow, IRC looks great. Lots of VJUG 24 comments. So without further ado, let me pass across to Ray, and let's talk about how we can manage and develop microservices using Kubernetes.
All right, well, thank you. So I'm going to go ahead and share my screen, and let's see that nice effect again. There we go. All right, cool. So I'm going to go straight to my slide, and yeah, are we good? Yeah.
Yeah, we're good. We can see your slides.
Sweet. So there we go. So my name is Ray. I'm a developer advocate, like Simon already introduced me a little bit. And if you have any feedback or any questions about the things I'm going to talk about today or about Google Cloud Platform, feel free to contact me on my Twitter handle @Satanism. And this is a photo of me. Actually, I use this photo because I'm kind of shy. I tend not to show my face in my profile pictures. However, I have an announcement to make. This very camera has been lost on the train about 3 weeks ago. So if anyone sees a Canon T1i with a broken screen, please let me know as well. And just yesterday, I was in Lugano attending Vox Day Ticino. And just this morning, I was in Como. And this is the photo from this morning. I'm officially on vacation, but I'm just very, very excited and very happy to be able to present on VJUG. So there's no way for me to skip over this. So I'm very happy to be here. And thanks, Simon, for inviting me. And if you want to see more photos, feel free to check out my Flickr. Anyways, let's get right into it. This presentation is not about the theories about microservices. I think that everyone has different use cases, and you gotta make up your own mind. But this session is just to show you how to use some of the tools that you can actually use to manage and deploy not just microservices. Actually, you can do this with any of your applications as well. So most of the presentation is going to be just a how-to and a demo, hands-on demo. And to show you what I'm going to do this is that well, I wrote this application a while back, and this is probably the most beautiful application I've ever written. I'm not a UI developer, as you can see. This is all Bootstrap, and it has two of the best demo applications built into one. It's got a guestbook, which saves and retrieves records from a MySQL database, and it's got this Hello World service that simply says hello to you. All right, so it's got two of the best world. And this is the high-level architecture of what this typical application might look like. And you have the front end in the front, and you have the back end, the Hello World service, and the guestbook service. And they have different dependencies on some of the stateful components like Redis and MySQL. In a traditional deployment model, where we are dealing with Java applications and server-side software, is that we potentially package all of these into a single package deployment file, like a ER file or a WAR file. And even though we may have developed the services separately, in the end, we combine them together into this one single package. And then you deploy that into an application server. But before you get to that, what's supposed to happen, right? I remember in my consult days, we had to wait maybe 9 months or so for our machine to be ready to be deployed, to be able to deploy an application into it. And I always thought, oh, why does it take so long? Well, one of the things I never thought about is, well, first of all, the machine has to be procured, shipped, racked, cabled, and then you have to install the operating system, the right version of that, and then you have to configure it, and then you have to deploy or install your packages, whether it's system command lines or whatever, and then you put the JVM to it, and then you install the application server, and then you configure your application server, and finally you deploy your year files or WAR file, and most likely it's probably not going to work the first time. This actually happens to me frequently, right? Because as you are going through that deployment and installation procedure, most of the time there's going to be like this huge runbook that somebody wrote, and somebody else would have to go through this runbook and line by line follow it perfectly so that you can set up the environment exactly as what you need to run your application. And it can actually be scripted, which is perfectly fine. It's actually nice to script. But again, if that script has something wrong with it, you're all of a sudden you're going to be able to deploy the wrong configuration to all of the machines. And you have to do this not just with one machine, but you have to do this with multiple machines as well. And that is actually quite complex to do. Now, in terms of microservices, if you're going down that route, or even if you're managing your applications today, one thing you're going to realize is that when you deploy these microservices, you're going to be deploying them in separate packages. It's not just one package anymore. It could be potentially multiple packages, whereas in my application, I have the front end and 2 dependent services, and that could very well be 3 different packages I need to deploy and manage. And of course, you don't run just one instance of each of these services. Why? Because you want HA, you may need to be able to scale out to handle the load. So all of a sudden, you're looking at like it's this exponential problem where you have 3 packages you need to deploy, and all of a sudden you're looking at maybe 5 instances each. Now you are running 15 instances of your application, and they all have to be interconnected together. And the traditional ways of potentially running one application, one instance of the application on a single machine may not hold anymore, because it's actually very hard to utilize 100% of the CPU or the resources on a single machine. So what you're going to look at, again, is to potentially run multiple instances of these applications on the same machine. And once you start doing that, then you have other complexities that you might run into. For example, well, first of all, the port can only be used by one instance at a time. So, because no 2 programs can share the same port. So you have to deal with port conflicts. And what I've seen before is like this big, huge spreadsheet where you have all the applications running on that machine and what port they're running on and which other ports they talk to, right? So you have to manage that. But then as you're running more and more instances of these services, you have to make sure that they are still up and running. How do you actually detect if something failed? If something failed, you actually want to have the tool to automatically potentially restart or remedy the situation for you. Again, like when you're deploying at scale, the manual intervention may be very cumbersome. So you want to have a tool to do this. And you also need to be able to scale out as the load changes throughout the day, or scale back in if you need to. And how do you actually test it? How do you actually deploy it in multiple environments? There are many things to think about. So to demonstrate some of these situations and also how you can deal with it with tools that we are going to show. Well, first of all, I'm going to show you the application a little bit. And the code is actually on my GitHub as well. And I have this really easy, simple Hello World application. There's no live coding today, but this is the application I wrote just to demonstrate very basic things so that we can relate to Kubernetes a lot better. So here I have a REST controller. It's written in Groovy with Spring Boot. And all it does is that it says hello to you, and it's going to take the template string directly from the application configuration. Okay, and it's going to return a JSON payload with the greeting itself, the host name, and the version of this particular application. And the application configuration is just in application properties, and it's a really simple template here. It just says hello to you.
Just a quick comment, Ray, to everyone listening. Sorry to interrupt. To everyone listening, I forgot to mention at the start. If you're having problems with the video quality, if you click the cog on the bottom right, you'll be able to see all the qualities, all the potential qualities you can download from YouTube. So just set the video quality to the highest you can, and that'll allow you to see the code and the consoles much better. Thanks, Ray.
Yeah, thank you. So the first thing that we're going to do is to potentially containerizing this application. Now, I'm going to assume many of the viewers may be familiarized with Docker already, but there are just a few things I want to show. First of all, containerizing your application is really nice because the way that you describe how to create the container image is actually self-documenting, right? So, for example, if I go into the Hello World service and let me see here. Let me go to 1. And by self-documenting, I mean that I can actually take a list of instructions on how to set up this environment as if I were to set this up on my virtual machine. But rather than doing that, I'm going to script it. I'm basically going to put this, in this case, in a Docker file. To build a Docker container, I can just put in the line-by-line procedures on how to build this environment. Right? It's very easy to do. And then I can run this locally on my laptop, or I can deploy this to the server. And no matter where I deploy this, the environment is going to stay the same, right? So that you don't have to go through this complicated runbook in terms of how you set up your runtime environment over and over again. But I don't know, usually I ask a show of hand to see who's using Maven versus Groovy and whatever. I just want you to know that if you use, say, Maven, and there's actually quite a few really nice Maven plugins you can use. Spotify actually has 2 of them. And the one I'm using today is called Docker Maven plugin. And this is nice because you can actually describe what your Docker image should look like directly in the pom.xml. And so, for example, here I have the base image, the name of the image, and how I'm going to start my application, and which files I'm going to include in my image that I'm going to build. But what's really nice about using a Maven plugin is that you can tie this into your Maven phases as well. So you can build a container image whenever you're invoking Maven package, right? So not only do you build your jar file or files or whatever, you can also build your runtime environment in that runtime image as well. What I actually like to do with Groovy and the Spring Boot is that I'm kind of lazy. So what I use is a Docker file that literally has only 3 lines of code here, 3 lines in the Docker file. And the thing I'm doing here is by using a very specific Docker instruction called unbuild. And what I actually do is that even though I'm inheriting a base image here that has Spring Boot and the Groovy pre-installed, but during the build process, I'm also inheriting some of the build procedures, the build instructions directly from this parent image. So that what this parent image actually do is that during the build time of this new child image, it's going to copy all the files I have into the build context and then compile it and create a jar file for me. And then all I have to do then is to say how I'm going to start it, basically, which is nice. Okay. And to build this, basically, you just have to do a Docker build. -t, the name of the image, and then dot, which is the current context. But I have something already built already, right? Then you can start this container the way that you want. If you need to run multiple services, and if you have plenty of other dependencies, what I like to do from a development perspective on a development machine is to use, say, Docker Compose. And with Docker Compose, I can actually specify all of the images I need to start. In this case, I'm going to launch the UI, and this UI has 3 dependencies, and then I can specify what all of these dependencies are based on the name of the image, right? And I can also configure MySQL directly as one of these components inside Docker Compose as well, and Redis, right? Because remember, my application has plenty of dependencies here. And if I want to run this, I can just do a Docker Compose up. And what this is going to do is basically just instruct Docker to start all of these components for me. And if I don't have any of these things pre-installed, like say, if I don't have MySQL pre-installed, it's going to fetch the MySQL image for me and so that you don't have to install this manually yourself, right? And same thing with Redis as well. So imagine a new developer who just walked, into the room with, join the team. And usually, when I do that myself, I'd probably spend like a month or whatever, a couple of weeks just to get my environment up and running. Whether it's the right version of MySQL with the right credentials and blah blah blah. Like all of those things will take a while to set up. But if you're using, say, containers to do this, then the process gets a whole lot easier. Okay, so I think my application is up and running, so I'm going to go ahead and see if it's actually there. And for the very first time, I should be able to see my application and can say, hello, VJog. Yay. And that should save it to the database and through the services that I created. And when I'm done with this, I can just go ahead and Control-C. It's going to delete all the containers for me, or the runtime for me. And if I were to do another test, I can just launch it again. Right, that goes up.
Just a quick question, Ray. We've got a question on IRC from Carsten's Rage.
Yeah.
He's asking, or she's asking, does Kubernetes require Docker images? So I guess it's probably worth outlining the relationship between Docker and Kubernetes and what they do.
Gotcha. Yep. So Kubernetes is a container orchestration tool or a container management tool. It is actually container agnostic. Container format agnostic. And what I mean by that is that Kubernetes is made to manage containers, but it doesn't really care about which format of the container is. So for example, Kubernetes supports Docker images really well. Kubernetes also can support Rocket. And in the future, if there's another container image format that's really popular, Kubernetes can also potentially support that as well. Okay.
Awesome.
Yeah. I think that takes us into a good segue into our next session here. So what is Kubernetes and how does that relate to Google? I'm just going to a very quick history here. Well, first of all, everything at Google runs in containers. And I do mean everything. Whether you're doing a search, whether you're watching YouTube videos, or maybe even watching this Hangout live right now, everything at Google runs in containers. Even the cloud platform itself and the virtual machines, they all run in containers also. So Google has many, many years and experiences in terms of understanding how to manage and run containers at scale, basically. Obviously, we're not using any of the container format that's out there today. And in fact, Google created this concept of resource isolation with C group many years ago, and we actually contributed C group into the Linux kernel way back then. And that is one of the fundamental technology that's necessary for containers to work in terms of resource isolations. We launch over 2 billion containers per week, and I just have to qualify this. This is not as much as it sounds, especially if you're in Europe, because I think in Europe, 2 billion means 2 million. This is a US billion, so it really just means 2,000 million, right? So we're a few order of magnitudes less, but there's still a significant number of containers that we're launching per week. So how does this actually work as an engineer within Google? This is what we do. First of all, rather than deploying my application to individual machines, which I know by name, right? At Google, we have so many machines in a single cluster. We don't actually do that. What we do is we just say, here's the application. I need you to run this in a whole cluster, entire cluster. And I can specify how many instances of the application I want to run, but I don't care which machine it actually runs on. And that's a very, very important concept here. And a single cell is what we call the cluster. A single cluster or a single cell can be composed of up to 10,000 machines. Now, again, imagine if you were to manage this manually, right? We actually don't do that. We manage the entire cell or the entire cluster in a single view as a single pool of resource, which is really, really nice. And you can actually do that with Kubernetes as well. And then we specify the binary package we want to run, and we specify some of the command line arguments, and then we can specify the resource requirements, how much RAM, how much disk, and how much CPU. And finally, we can say how many replicas. This is really how many instances of the application we want to start. And in this case, we're going to ask for 5. But if you want more, you can easily just change the number of replicas to, say, 10,000 instead. And then you can just go ahead and deploy it. And the way that it works behind the scenes looks something like this. If we first put the binary into a central repository somewhere, and then the config file I just showed you, we send it through our tool. Our internal tool is called Borg. And there's a master node concept where the Borg master is the one that's responsible to receive this configuration file, and then it's going to consult the scheduler and check with all of the machines. Remember, there are about 10,000 machines here. It's going to check with the machines to say, hey, do you have enough resources? Do you have enough capacity to run this particular application or to run this particular job? And if you do, then that computer will then pull down the binary file and start the job. And if you don't, Borg will just simply pass over you and try to find another machine that has enough capacity to do this. And we can then see all the application, kind of getting deployed and getting started in our data center in a single cell this way. And we can do this very, very quickly. We can launch about 10,000 jobs in about 2.5 minutes. And that's not bad. That's actually extremely fast, considering that many of these images can be large. Now, we build these applications in a static manner so that any one of these applications could be like 30, 40 megabytes large. If you're dealing with, say, containers, then it can be much, much bigger, say 200, 300 megabytes large, depending on the type of the base images you use. But we are able to do this very, very fast because that within our data center, we actually have some really awesome custom networking technology that we can go up to, say, 1 petabits per second in terms of bandwidth. Okay. Now, if you put this in terms of how does that compare? I think if I recall correctly, the entire internet runs about 250 terabits per second, and we're already 4 times over that within our data center. So we're able to distribute our packages very, very quickly through our internal network. And you can read more about this by searching for, say, Jupyter Superblock, and you can read about our technology that we use. And again, if you're on Google Cloud Platform, you kind of get the same data center, you get the same technology as well, and the same benefit. Okay, so what is Kubernetes, and how does that relate to that, to Kubernetes? Well, so what Google has done is that rather than taking Borg as is and open sourcing it, we actually created a brand new project called Kubernetes, and it is based on all the experiences that we have had in terms of managing and orchestrating containers. It's fully open source, it's written in Go, and you can actually run Kubernetes and manage machines in multiple environments. What I mean by that is that you can run Kubernetes in Google Cloud Platform, you can run it in other cloud platforms as well, and you can also run this on bare metal environments in your own data center, right? So regardless how and where you run this, once you model your application based on Kubernetes, say, configuration files, then you can actually deploy your application or actually your architecture to any of the Kubernetes target, whether it's in the cloud or on-premise bare metal environments. It doesn't matter. It's the same application. You can actually deploy it anywhere that you want. And it's a very, very vibrant open source project. It's on version 1.2, and we have many, many contributors. And in fact, there are actually more non-Google contributors now than Google ourselves. And the whole project is also managed by a separate foundation as well. And as you can see from the list, there are many partners and many companies who are extremely interested in this technology. Okay. And this is how it works behind the scenes. For me to make this slide is very, very easy. I just had to copy and paste the previous slide and do a search and replace. Right? I just replace the name Borg with Kubernetes, and I'm pretty much done. So rather than, say, a binary file that we deploy internally, in Kubernetes, we manage containers. Like I said before, we're a container image agnostic. So today, we support the Docker and the Rocket, and in the future, we could support other things as well. So first, you push the container image into a repository. If you're using Docker, this could be a Docker registry. And then you can write a config file on how you want to deploy or describe how your application should be run. And you can deploy that config file into the Kubernetes master, and then the master node will console the scheduler, and in turn it's going to check with all of the machines, and if the machine has enough capacity, then Kubernetes node will go ahead and download or pull down that container image and then start the application that way. Yeah, pretty straightforward, pretty easy to do. And here's a simple config file that you can write, basically the name of the application you're going to run, the image that you need to launch, and some of the resource isolation parameters, if you have any, and how many instances you want, basically. So rather than looking at the slides, I like to go back to the demo and see if everything still works. So I am going to do this by running a visualization tool. Okay. All right, it's still working. Good. So in this visualization tool, we can see that in my Kubernetes cluster, which is running in Google Cloud at the moment, under the what we call container engine. Google Container Engine is basically a managed version of Kubernetes, where we actually manage all the machines for you. We manage the installation of Kubernetes components. We also manage the upgrade of Kubernetes versions if necessary, so that you don't have anything that you need to do yourself. Basically, you click a button and say how many machines you want in the cluster and how big the machine should be, and we'll go ahead and provision them, and out you have the Kubernetes cluster. So here I have a cluster with 4 nodes here, and I just want to deploy the application, the Hello World application that I just showed you earlier, right? So I'm going to start with the Hello World, and then if I have time, I'm going to go and build the entire stack of the application for you. So to run an image in Kubernetes is very, very easy. I can just do a kubectl run. Hopefully you can see my screen. Kubectl run, the name which I can make up myself, and then the image I want to start. I have the image on Docker registry right now on Docker Hub, and I'm using the tag 1.0. Right, that's the image I want to start. And then here is something very, very important with the -L. That just means a label. And a label is a very important concept in Kubernetes. Anything that you provision in Kubernetes can have a label. And the label is nothing but the key value pair, or you can actually make up your own key. So for example, here I can make up a key called conf is vjoc, and I can say the environment is staging. I can say the version is 1.0. I can say the application name is Hello World Service, and visualize is true just because I want to visualize it in my visualizer. Okay. So rather than adding all of those different labels, I'm just going to go ahead and do something simple. I'm just going to code the label app is Hello World Service and visualize is true. And if I were to run this command right now, what this is going to do is to actually invoke an API in Kubernetes and go ahead and provision the application for me. And all of a sudden, you see in my visualization tool, 2 boxes appear. What happened then is that the basically generated some kind of configuration for me, deployed it to Kubernetes master, and Kubernetes master actually went to check with all the nodes with the capacity that's necessary to run this one application. And now the application is actually up and running. And the box in gray, that's actually the application instance. And I'm running one instance right now, and it's running on the machine TPLA. And it's one of the 4 machines that I have. This box, this gray box is very special. It's called a pod. Now, most people would be like, wait, hold on a second. I thought we were talking about containers. What is a pod? Well, in Kubernetes, a pod is actually the atomic unit that it actually manages. It's not containers, but a pod. What is a pod? A pod is really a collection of containers that's tightly coupled together that has to live and die together, and that they share the same, say, IP address or potentially the same value amounts. They are guaranteed to be scheduled onto the same machine. So if you run 2 containers in the same pod, they will be running on the same machine for sure. But what that also means is that when you're scaling out the number of instances of pods, all those containers in the pod will be scaled out as well. Now you might be thinking, okay, so we have this simple application that has the front end and the 2 back end and the MySQL and Redis, right? Are they tightly coupled together? Do I put them in a pod? Well, if you do, what that means is that when you scale out the number of pods, you're going to have multiple instances of MySQL and multiple instances of your backend and the same number of instances of your front end. You don't really want to do that because each one of these layers should be scaled out independently. right? So that's not a good use case. What would be a good use case for multiple containers in a pod is, for example, if you had a logger, right? If you have, or a metrics collector. So if your application is exposing metrics, say via GMX, and you need to collect those metrics from another agent, and that agent lives with the application, then you can actually run the agent along with the application as a separate container in the pod. And then as you scale out your pod, you also scale out the number of agents that you have. That's really, really handy to do. Okay. One of the other important thing here to note is that each one of these pods has a unique IP address as well. So here in this instance of the pod, it's got an IP address 10.12.5.3. It's an internal IP. But the important thing here to take away is that these pod IP addresses can actually talk to other pods as well, regardless of the node that they are on. So there's actually internode or interpod communication. And this is achieved through some kind of overlay network, or just a static routing between all the nodes. That's very, very important to know. But also because every pod has a unique IP address, your application instance can all use the same port because they're all running on the same port, but on a different IP address. Now, the box in blue, that's what we call the deployment. And sometimes you can think about this as a way to scale out the number of application instances that you want. Okay, so for example, if I need to scale this out from one instance to multiple instances, I can do a kubectl scale, and the name of the deployment and hello world service. And rather than one instance, we can do say four instances. So once Kubernetes receives this command, it's going to go ahead and provision multiple instances. And if you look closely, they're going to be running on different machines as well. Kubernetes is going to try to schedule these applications out as evenly as possible based on its resource needs as well. Okay, so that's pretty easy. I can scale out and I can scale in if I want to. There we go. So if I say replicas is equal to 3, and it's going to kill one of the pods. Not only that, Kubernetes will actually guarantee or try to make sure that the number of instances or replicas that you ask for, that's your desired state. If your current state is anything different from your desired state, Kubernetes is going to try to remedy it. What I mean by that is that if I were to, say, delete one of these instances, okay, so I'm going to delete one of these random instances. Now, because of my desired state is, say, 3 instances, if I were to delete one of them, they only have 2 left. And in this case, Kubernetes will actually recognize that and restart another instance for me very, very quickly. And this goes by so fast, you probably saw a little blip in the yellow thing. That just means that one of the instances was gone and another one was already being started. Now, one of the most common questions I get as part of this, going through this part of the demo is, okay, great. Now, every pod instance has a unique IP. How do I get consumers to consume this application? Well, obviously, giving the consumer the individual IP addresses probably wouldn't work because these IP addresses are ephemeral. They come and go, and there's just no way for you to be sure which IP address will be there now and will be there next. So usually, to solve these type of issues, we provision a load balancer. And in Kubernetes, load balancing is actually a first-class concept, and it is a concept called a service. So for me to create a load balancer for this set of services, all I have to do is to do a kubectl expose, the deployment, hello world service, and I can give it the port number, 8080, and which port I want to load balance, which happens to be the same one, port 8080. If I were to run this, then you're going to see this box in green, which is actually a service that's being created, is actually a load balancer that's being created. And this particular load balancer is called a cluster IP service. And what that means is that this only has an internal IP address, but it's stable. As long as the service is still alive, this green box is here, it's going to keep this IP address. So now you can actually make a request to this IP address, and then will be routed to any one of these 3 gray boxes, or your application instances. So if I were to scale this out again, it doesn't matter how many instances I have, as long as I'm talking to this service in green without stable IP address, Kubernetes will then route the traffic for me whether to a healthy instance behind the scenes. How do I actually get to it? So let me just show you that if I were to get a list of pods, and I have here a shell I am running inside of Kubernetes, and for me to get back into that shell, just like Docker, you can do a Docker exec. In Kubernetes, you can do kubectl exec and ti, and then the name of the pod and the command I want to execute. And that should drop me directly into this application instance, the demo application instance, and now I'm running a bash shell directly inside Kubernetes within that container, which is really, really handy when you need to debug or troubleshoot things, rather than SSH into the box first and then find out Docker container running and then do a Docker exec. You can just do kubectl exec instead. Okay. And so I can just go ahead and do something like make a request, 10.15.246.162, port 8080, and I'm going to get a hello. Let's see if that works. There we go. So I just got a response back. But I don't really want to, again, keep track of these IP addresses. Again, what if it changes? So in Kubernetes, there are actually built-in ways to perform service discovery. And there's 3 ways, but I'm only going to talk about 2 because those are the better methods. First of all, you can actually get a list of services directly from the API. So if I were to go to the API, I can actually get back a JSON payload with all of the services that I have. And here, if I were to find the hello world service, I can actually see the details and potentially the IP address I need to get to that service. And you can also do the same thing with the pods. So if you know the labels of your pods, you can actually search for the pods, and then for each of the pods, you can actually get an IP address as well. Okay. But the other way, which I prefer, is to really just use hello world service. I can actually use, for example, DNS lookup. So with this specific installation of Kubernetes, if you do this on, say, container engine, we add the DNS discovery right off the bat. If you're running this on your own, you just need to run skydns. There's a little YAML file you deploy, and you can get the same. You can get the same capability. So what I'm going to do is then say curl HTTP and hello world service port 8080 and hello Ray. And there you go. It actually resolved for me to the IP, and so I can make that request. Pretty cool. All right, let me get out of there. Let me go ahead and, because of the time, I'm going to go ahead and deploy the rest of the stack. Okay. So remember, in my application, I had the MySQL server, I had Redis, and then I have 2 other services I need to deploy. And for those, because the configuration is a little bit more sophisticated, so I actually just wrote the deployment file. So for MySQL, for example, I have this deployment YAML file where I can say which image I want to deploy. And in this case, this is MySQL image directly off of Docker Hub. I can pre-configure it with the username and password. And because MySQL is stateful, I actually need to save my data somewhere. And to do that, in Kubernetes, you can actually do a value mount. And the type of value we can mount is actually, there are quite a few different types you can do. You can mount a host file system if you want to. But if the host goes down, then you also lose the data, right? Well, in the cloud, you can also, say, provision a disk in the cloud. So, for example, on Google Compute Engine or Google Container Engine in Google Cloud Platform, I can just go ahead and provision a Google Compute Engine disk. And then I can refer to the disk by name, and then I can just go ahead and mount it into the path var-lib MySQL. That's where the data lives. If you're on another cloud, if there is a support for that value mount, then you can also specify it here. Rather than GCE persistent disk, you can just specify something else. If you're on-prem, then you can do, there are many, many things you can do. You can do RDB, you can do iSCSI, you can do NFS. And all it takes is to configure it here, and then you decide on which value, which path you mount it to. Okay. So I'm going to go ahead and deploy this, and the one I'm going to do is to do apply f deployment, and I'm going to also deploy the service as well, because that's really, really important. I'm going to record this change in my Kubernetes architecture here. So I'm going to go ahead and do that. And that created the MySQL stuff. And once it's deployed, I should be able to see it on my screen. There you go. So now I have the MySQL pod that's in gray. The deployment, that's making sure that my MySQL server is up and running at all times. And then I have the service that's in green, which is what my consumers will be hitting to connect to my SQL instance. Okay, and I can do the same thing with Redis. I can do the same thing with the rest of the services. So to save time, I have this one other script, which is turn up or say deploy. And what this is going to do is just going to go ahead and deploy everything for me. Okay. And because my environment is so being kept in a container, so I can actually deploy this anywhere I want. And then my entire architecture and how many instances I want and what services I want to expose, that's all saved in the Kubernetes YAML file. Then I can actually recreate this entire application or this entire system, which is composed of multiple applications in one shot. So now I have, you can see very clearly here, I have the UI running with 2 instances that's managed by the deployment here. And the UI is talking to the guestbook service. You can follow the yellow line, which that's also talking to the Hello World service. And for session replication, it's talking to the Redis instance as well. And you can see that they all talk to the service instances rather than the pods individually. Okay. Now, what I've done here also is that when I created all of these services, for the Hello World UI service, I did something very, very special. If you notice, most of these services are using the 10.15 or 10 range, right? And the 10 range is actually the private range. These are private to the cluster, and you cannot get to any of these services from the outside world. But for the UI, for the website, I actually want to expose it as a real endpoint on the internet in the cloud. And so what I had to do there is to let me open up the file. And what I had to do there is to specify the type. Rather than not specifying a type, I just specify the type as load balancer. And that, what is that going to do is to create a real load balancers behind the scenes for me. And again, on Google Cloud Platform, the load balancer that's going to create is actually a real Google Cloud load balancer that's going to route traffic for me. And depending on the environment you are on, it's going to create different type of load balancer. You can even customize it if you have your own hardware load balancer as well. So now in this Kubernetes systems, if I were to go to this URL, I can see that the application is up and running, and my name is Ray, and hello, it worked. Phew. Actually, it doesn't work until, yeah, there we go. Now it actually works. Fantastic. So, and then I can really easily scale any of these other services out or in case that I need more Hello World UI. All I have to do is to go ahead and say scale, deployment, Hello World UI, and say I need 3 replicas, and that's it. Now, some of the other things and newer things I want to show you, for example, is performing a rolling update with deployments in Kubernetes. Okay, so right now I have the UI running on version 1.0, and I'm going to do something daring here. I failed this last time about 2 days ago, but I'm going to try this again. So I have here the Hello World UI source code, and somebody from marketing told me that the white background doesn't work really well, okay? And I've been recommended to change it to blue. So what I'm going to do then is to go ahead and modify my template. And let me see here, here, background color is light blue, something like that, okay? And once I've done that, I can go ahead and build this container. Let me see if I have this queued up. Yep, so I have Docker build, I can build this container. This is live, by the way. Yeah, there we go. So it's going to go ahead and resolve the dependencies, build the Spring Boot application for me, and done. Now, for Kubernetes to get to this container, of course, I have to put this into a registry. I have to store it somewhere that Kubernetes cluster can get to. So for that, I'm going to go ahead and tag it. I'm going to tag it with a special name here. Again, you can use Docker Hub if you want to. And in my case, I'm just going to go ahead and use my private registry that I get for free, basically, out of the box with the Google Cloud Platform. I just have to pay for the storage. So here I'm going to say GCR Wise Coyote. That's the name of the project. I'm going to tag it with say vjug. Okay, that's it. And then I can go ahead and push it. So I can do gcloud docker push and the name of the image. This is how I can push to my private registry. Okay, and just give it a second to log in, and there we go. It's pushing the new version of my application. Just give it a second here, and that's it, done. Now what I can do, and this is really, really cool, I can go ahead and deploy this in replacing my existing application with a rolling update. So what I can do is I can do kubectl edit deployment, hello world UI. I'm going to record this change. And here I can say that, okay, now I have 3 replicas, and I'm going to go ahead and change the label to 2.0. And here the image, I'm going to replace it with the new image which I just created. And on the top here, I can say, well, how many maximum instances can I deploy at once, because it's rolling update, right? And how many unavailable do I want to have? So for example, I can say, I want to make sure everything's still running, and I can have at most 1 new version at a time. So I can just go ahead and change it. So why don't I do that? Okay. And now if I were to save this, now watch the visualization tool. If it works, come on. What it's going to do, hopefully, is, let me refresh it. Oh, there we go. Oh, a little bit too fast. Okay, so now you can see on my tool here that you can see there is clearly 3 instances of version 1 still running, and version 2 is being brought up. Nice. And because I also have configured health checks. Let me see here, readiness check. So in Kubernetes, there are actually 2 types of checks you can add. There's a liveness check, which check whether your application is up and healthy. And then there's a readiness check, which is really what it means is that even though your application is up and healthy, but is it ready to serve traffic? Okay. In some cases, you may need to start your application and then warm it up a little bit. So it's not ready to serve yet. So we have distinctly 2 different checks here. And the checks, you can do a HTTP GET, you can do HTTP SGET. You can also do a port check. You can check whether the port is up and accepting connections. Or you can also run a command line to check whether your application is healthy or if it's ready to serve. And now because I have a readiness check, the rolling update will only replace another version or start deploying new versions when the previous instance is still healthy, right? Because when I'm starting my 2.0 application, I'm waiting for like 5 or 10 seconds for it to become healthy and become ready to serve. And now everything is up to version 2.0. And if I were to, if I'm lucky, if I refresh, yes, all right. If I refresh the page, you can actually see that this is now blue. Fantastic. Now, wait a second. Now, actually, some people came back and said, you know what, blue doesn't work so well. I need this to be rolled back. And how do we actually do that? Well, in Kubernetes, with deployments, it's really easy. You can say kubectl. You can actually see a rollout history. You can see the history of all of your deployments for this particular application, right? So I can see that previously I changed the scale to 1, and I edited the deployment in revision number 2. And if I don't like the blue background anymore, I'm like, I need to do a rollback because this is a bad deployment. What I can do is to do a rollout, kubectl rollout, undo, and then the deployment itself. Okay. And if I go back to the visualization tool, what this thing will do is to go ahead and replace the 2.0 version with 1.0, again with a rolling update as well. So it's going to replace the 2.0 version as soon as the 1.0 version is up and healthy. Really, really nice and easy to do. In addition to this, you can actually use deployment to manage many other aspects of your application. So for example, the last thing I'm going to show is that this hello response. Right now it says hello Ray. And I can actually change it if I want to. And there are many ways I can change this configuration. Because I'm using Spring Boot, there are actually 3 ways I can do this. I can override the configuration with the environmental variable, or I can override it via a command line argument, or I can actually specify the application property file that I want to use instead. And in Kubernetes, there's a really handy way for you to actually store your configuration directly inside of the Kubernetes cluster, and that is called a config map. So I already added the config map here, but I can do a Git Config Map. I already have a config map here, which I created previously. It's really easy to do. And you can actually edit the config map as well, so you can see what's inside. In this config map, I have greetings, it's a hello, and then you can see the config map change here. Right, I can actually change it. I can just remove the rest of this, and then I can go ahead and save it, and that's it. And then your application can actually refer to this configuration map as well. So I'm going to do a kubectl edit, my deployment, hello world service, I think. Very good. And let me see here. For me to reference to that configuration resource, which I put inside of Kubernetes, I have to do 2 things. Well, first of all, I can refer to that configuration file as a volume. So I can do volumes, and I can give it a name, config. And here I can say it's a config map with the name of, let me double check here, kubectl get config map. I think it's called myconfig, okay? And then I can access this, I can mount this configuration as a volume. So I can do volume mount. And I can say the name is config, which is actually coming up from here. And then I can say the mount path is say etc config, for example. Okay, so I'm just going to do that right now. It's very easy to do. And then what you're going to see, whoa, hey, let me refresh it here. What you're going to see is that very, very quickly, my hello services actually got restarted, and with the new configuration mounted in the file system. So if I were to do a get pods, and if I go to one of these things inside the pod, so I'm going to go again into the pod and see what is actually there. And if I go to etc config, and I can actually see the application properties, that's nice. And if I refer to it, that's the content that I have, right? And very lastly, before I hand this back, I'm going to use this new configuration. And the way I'm going to do this is by specifying the command line argument. And I can say spring dot, I think it's config.location is equal to etc config application dot properties. Okay, I'm going to go ahead and save it. Again, it's going to go ahead and do a rolling update on my application, and it's going to kill one instance and start another one with a new command line. And while this is working, if it's ready to work, then I should be able to refresh this page. There we go, and you can see the new configuration. And that's really it. And once you're done with all of these services and all of your application, you can destroy your environment very, very easily. And this is the last thing I'm going to show, is that you can reset everything into a clean state if you want to, simply by deleting all of the resources. You can go ahead and delete the services, you can delete the pods, you can delete the deployments, and ultimately you're going to be able to restore your application or your environment basically into the original clean slate. And now you can deploy something else. Now, what if you have to deploy multiple applications, or you have multiple teams, or that you have multiple projects? There's one last thing I want to mention, is that there's a concept of namespaces in Kubernetes. So you can actually create a namespace for your application or for a set of your application components to run in. You can have a namespace for prod, for example, or you can have a namespace for a team. And each one of the namespaces can have a special quota. You can say, a production environment, you get 30 CPUs. In the staging namespace, you only get 2 CPUs, right? You can actually set the quota at the namespace level. And all the applications within the namespace will be then constrained by that namespace's quota as well. Or if you have multiple teams, you have a team that needs more resource than the other, you can assign a namespace to a team, and that namespace can also have a different quota requirement, so that different team can share the same cluster, and they wouldn't be able to step over each other. And that's really all I have for today. And if you are very interested in this technology, please go ahead and definitely check out Kubernetes.io. It's a very, very good way to learn more about Kubernetes. All of my source code is actually on GitHub, which I'll share later as well, and also share on Twitter. And if you want to try this on the cloud, go ahead and try this on Google Cloud Platform, and you actually can get some free credit if you want to sign up for the first time as well. So that's all I have. And Simon, I'm going to hand this back to you and start my screen share.
Awesome. Thank you very much, Ray. That was that was fast-paced and awesome. We got through a lot there.
Yeah.
We have a whole bunch of questions, actually.
Okay.
In fact, Despair has been answering a whole bunch of them on IRC as well, but I'll pass them over to you as well, just so that we can get them on video.
Sure.
If anyone else does have questions, we can go over. That's fine. So please do ping them straight into IRC. I'll try and get to as many as I can.
Yep.
So Dr. Geb asks, you mentioned something along the line that Docker file is self-documenting, and that you can run commands in a virtual environment by copy-pasting. Is there any tool that can take all the instructions from Docker and just run them on the machine directly, so automating the process, making the Docker file more reusable?
Actually, you know what? I think there's a tool. I don't remember the name of it, but somebody actually took those command lines that you specify in Docker file and tried to run this on the local machine. I remember there's a tool. I just don't remember the name of it. Yeah.
Okay.
Sorry about that, but I'll find
no worries. No worries. So Dr. Jeb, if you ping Satanism on Twitter, I'm sure you can do that offline. So JJ asks, how is load balancing handled? Dspare gives a few options, including HA proxy, other load balancers like Apache Zookeeper or Consul.
Gotcha. Yeah. So load balancing in Kubernetes right out of the box with a private IP address. It is actually in 1.2. It's actually done through IP tables. Okay, so it's actually very, very fast and performant. If you want, you can also have an extension to use, say, HA proxy. In fact, previously, Kubernetes used a software load balancer called kube proxy, and the process is very similar. If you want to expose, say, a full, like, say, HTTP endpoint, for example, with L7 load balancing, you can actually do that in Kubernetes 1.2. It's called an ingress resource. So with ingress, what you can do is to expose with a real HTTP load balancer rather than a L3 network load balancer. And what that also means is that you are able to do virtual host routing. You can also do static packet-based routing as well. And you can route to different backends. You can route to different services based on the path. So that's also very, very useful. In the cloud, in Google Cloud, we'll actually create a real Google Cloud L7 load balancer. On-prem, you can actually use Nginx for that. And if you really want to, you can write little plugins to talk to your own hardware load balancer if you need to.
Okay, awesome. M. Rodorus asks, are the resources declared in the job description file, such as CPU equals 0.1, blocked exclusively for this pod container, independent if the resources are actually used?
Gotcha. Yeah, that's actually a slightly more advanced topic. There are actually a couple of things to consider. Kubernetes actually overcommit by default. What that means is that if you specify I need say 1 CPU and you have 4 CPUs on the machine and you deploy 4 instances, you are still able to actually deploy another one because most of the cases we overcommit so that we get the best utilization. If you need guaranteed reservation, in Kubernetes, it's actually the resource request, which is what you want to get. And then there's another thing called the resource limit, which is the most that you can get. Okay. So what that means is I can request 1 CPU and burst up to 2 CPU. And if the request and the limit is the same, then if I recall correctly, then the reservation becomes guaranteed. That means we'll actually not schedule anything else if you already need that CPU utilization. But otherwise, it will be overcommitted.
Okay. A couple of questions, actually. Both Tool Dave, which is a great handle, and Gravesh Both ask, is the visualization tool part of Kubernetes, or what's it called?
The visualization tool is not part of Kubernetes. I get these questions all the time. Although in Kubernetes, there's a little thing called the Kube dashboard, which is kind of nice to see as well. But for my demo, the visualization tool I use is actually on my GitHub. So it's on github.com/satanism. You'll see a little Kubernetes visualizer there. Yeah.
Perfect.
And the instructions to use it.
That's GCP Live K8s Visualizer.
Yeah, yeah.
And that's right. Thanks, Rob Brum, for putting that into IRC as well.
Yeah.
Okay, Nikatsa asks, can my application themselves make use of the load balancer for communicating between them without the need of a discovery service like Zookeeper?
Yeah, actually, you can actually do that. When we create the service, Kubernetes actually already have a list of endpoints. You can actually get access to all of those endpoints individually if you need to do, say, a client-side load balancing. If you want to do, you say a load balancer to load balance it for you, then all you need to do is to get that stable IP address or get that DNS name and just send your request to that DNS name, and that will then behind the scenes route the traffic for you. And when a node or a pod goes up and down, when you're scaling in and out, we will actually make sure that we only say route the traffic to the pods that's ready to serve.
Okay. 3 more questions before we go, because we're a little bit over now. 3 more questions. One's an easy one. Can you share your the scripts and sample configs after the talk? You've already said yes to that, so that's great. We'll grab. In fact, Ray, we'll grab as many URLs as you care to pass us, and we'll make them available in the write-up for this talk. Second question: is it possible to use Kubernetes on AWS from KYFran02210?
Yes, absolutely. Yeah, it's definitely possible, and there's a very simple setup instruction as well, and you can find this on Kubernetes.io, the website.
Okay, awesome. And we'll finish with one last question from Rob Bram. Is it right that the service or load balancer is not aware of the session if there are multiple pods? How do I handle stateful applications, configure my own load balancer to redirect the user to the same pod, or do session replication with something like Hazelcast? What would you suggest?
Right. Yeah. So it is correct that the load balancer does not currently handle what do you call it? The session affinity with a cookie. However, it does handle session affinity with a client IP and or client IP and protocol. So that's pretty sufficient for most of the use cases. So you don't really have to worry about that in that particular instance. But if you do have to use a cookie-based session affinity, then yes, you probably need to configure your own. But you can actually do that if you really want to. You can replace the plugin, for example, to provision your own load balancer instead. And for session state sharing, you can run, say, Redis if you want to. You can do InfiniteSpan or Hazelcast. In fact, both InfiniteSpan and Hazelcast has some kind of discovery mechanism for Kubernetes as well. So it's going to use the Kubernetes API to discover other Hazelcast nodes or other InfiniteSpan nodes using the Kubernetes API, and then cluster those nodes together. And then all of a sudden, you are doing some traditional clustering and session replication like done previously. Yeah.
Which is pretty much taken care of under the covers, though.
Yeah, exactly. Yeah, I have a different demo which I can probably show in the future, but that's exactly what I do.
Awesome, wonderful. Well, it's clear that we've got the expert here for talking to us today, so that's awesome. So I think we're pretty much out of time now, but it was awesome from start to finish. It really was. If anyone does have any other questions, you can either comment directly onto the meetup page, but it's probably actually easier just to ping Ray straight on Twitter. Satanism, I think Oleg put that in the IRC earlier. Yeah, definitely do ping Ray, and if you are fortunate enough to go to a conference, do make sure you grab hold of Ray and have a chat with Ray. He's a really smart guy, a really friendly guy. So make sure of that. And Ray, I'm looking forward to having a beverage with you at some point in the future at a conference. Okay, awesome. Thank you very much, Ray. Thank you very much to everyone who's been on the session. Don't forget to look out for tomorrow's VJug 24 announcement. I'm still super pumped for that. Ray, I'm demanding a submission from you for the CFP. One other thing to note is the day after tomorrow we'll be recording the Java Council podcast, and we've got a couple of really great people on that as well. We have Reza Rayman, one of the leads for the Java EE Guardians, and we also have a supporter of the Java EE Guardians in someone, what's his name? James Gosling. James Gosling, that's the guy. I almost forgot, yeah, his name. Yeah, so James Gosling, yeah, that guy who I think he's done something in the past, maybe create a language or something, I can't remember. Founder of Java, 20 years ago. So really pumped to have James Gosling on as well. So do listen out for that. That'll be on announced on Twitter at Virtual Jug. So that's pretty much all we have. Ray, if you stay on the line, and we'll have a quick interview straight after this. Do look out. That was very dry humour. Thank you very much, Mr. Green. I'm British. What can I say? That's all the humour I get. And yeah, do look out for that on the Virtual Jug handle. And Ray, let's have an interview. So everyone, thank you very much for your time. Ray, thank you very much for the masterclass, and Oleg, you've been awesome on Twitter as usual, and Oleg's going to be interviewing Ray next. So thank you very much, everyone.
Thank you.